Welcome to the April meeting of the Royal Astronomical Society of Canada, Ottawa Centre, which is way too long to say 3 times quickly. Welcome to the Astronomy Club. Any members of the public here tonight? Welcome. Today we're going to have our usual format of a large number of people traipsing up and down the stage to tell you about observing you can do, observing that they've done, fun they've had in exotic places, observing reports and observing challenges. I have a slightly unusual format tonight. We're going to have a special intermission in the middle, which I'll describe at the time. And as usual, we have lots of free stuff to give away because everybody likes free stuff. First up, please welcome a new face. Stephen McIntyre, who's going to present our regular Ottawa Sky segment.
Microphone. Good evening. So I selected just a few highlights that from the evening sky in April, focusing only mostly on small scopes and binoculars, objects that are great for those.
Is
Is the microphone on?
Tap the mic.
How's that?
For the sound.
It's this one's on. So
Is that one working?
testing, yeah. I'll use that. I'll just stand closer to this one. Yeah, so the objects I've selected, just a few of them are best for, are great for small telescopes and binoculars, or just if you want to go out in the evening sky and look at the constellations. So if you're just learning the constellations or you rely too much on the computerized go-to scopes, I find it's best to go out in the evening sky. So about an hour after sunset, probably about 9 o'clock in mid-April and looking south, you'll just see a small selection of very bright stars. As the evening progresses, the stars start to fill in, and you can then sort of anchor your points from the bright stars and then pick up the constellations. About a half hour later, the 3rd and 4th magnitude stars start to show up and fill in the sky. Setting into the west in April is what's known as the winter hexagon. Capella, Aldebaran, Rigel, Sirius, Procyon, and Pollux. The brightest object in the sky in April, and actually just the brightest star in the sky north and south, is Sirius at magnitude minus 1.4. Directly south is Saturn, passing below the constellation Leo the Lion, with Regulus being the bright star just to the left, or just to the right of Saturn. Rising in the east, we've got Arcturus, the bear guarding Ursa Major, and it's also the left foot of the constellation Bootes, the plowman. In April and spring, Ursa Major, also known for its asterism, the Big Dipper, is high overhead, and using the front edge of the Dipper, you can find the North Star. At magnitude 2.0, it's not the brightest object in the sky, but there aren't, it's the brightest object in that area, making it fairly easy to see. April's probably your last chance to see M42, the Orion Nebula. By the end of April, it's going to set before it's dark enough to see. So as the middle star in the Sword of Orion, in a dark sky, you can probably just make out that it's something a little bit more than a star. In binoculars, you start to see the nebula. And in a small telescope, it probably appears more black and white than the colorful images that we're used to seeing. And at the center of the nebula, it doesn't show up in this picture, but 4 bright stars known as the trapezium, and probably see them in a small scope and a medium scope. They're fairly easy to see. Just to the left is in the constellation Cancer, is probably the best deep sky object for small telescopes and binoculars, the M44 or Beehive cluster. From a dark sky, a reasonably dark sky, you can probably make out a fairly obvious fuzzy patch in the middle of Cancer. You can locate it by finding Procyon and Castor in Gemini, and then moving about a hand's width and a half to the left, and then you'll see that fuzzy spot. In binoculars, you probably pick up at least a half a dozen stars, and in a small telescope, at least 100 or more. Yeah, at low magnification, probably 20 times to keep the field of view and not any tighter than about 1.5 degrees. Also in Cancer is another fairly bright open cluster, M67. You'll need binoculars to see this one. In binoculars, it'll show up as a fairly compact, fuzzy spot with a central star, reasonably bright 6.9 magnitude star. Looking north, then, just to about a hand's width and a half above the front lip of Ursa Major, are a pair of galaxies, M81 and 82. Even in binoculars in a dark sight, they're probably a challenging object to find, but it's kind of neat because within a single field of view, probably about a half a degree field of view, you can catch both objects. In a small telescope, the shapes will just be discernible, M81 being the spiral galaxy and M82 being the spindle-shaped galaxy. Everyone's favorite object, Saturn, is in a great position in April, fairly high in the sky at not too late at night. The rings are only tilted about 3 to 4 degrees at this time of year. It happens twice in the 29.5-year solar year for Saturn. If you're straddling the Cassini probe looking at Saturn, it's probably going to look like that, or in a highly processed photograph. From a more modest telescope, it's probably going to look something more like that. And in a small telescope, even pushing the magnitude at 200 times, this is probably the image that you're going to see. Now, in a telescope, you're going to actually pick up a lot more detail than that's visible here. April 26th, Mercury in the evening sky is at greatest elongation. It's going to be your best opportunity to see Mercury in the evening. Late in the fall, Mercury will make another appearance in the, another good appearance in the morning sky, but this is your best opportunity in the evening sky. So looking west on April 26th, just around 8:30 or about a half hour after sunset, Mercury is going to be 13 degrees above the horizon. That's just a little bit more than your hand's width above. Also, to make it easier, there's a day or two old crescent moon that's about 5 degrees above Mercury, so that's about 2 finger widths above Mercury. So it should make Mercury fairly easy to see, and it's probably a pretty good photo opportunity as well. So that's just some of the highlights said suitable for small scopes and binoculars, and I'll just leave you with some of the sort of dates and times or some of the other highlights.
Thank you, Steve. I'll use a sign of what I can get my observatory roof open. There's also another sign, which is my favorite, is spring is actually the best time to observe galaxies because of the position of the Virgo cluster and the Coma cluster, etc. And a really entertaining, efficient way of observing galaxies is to observe galaxy clusters. Please welcome Sanjeev to talk about observing galaxy clusters.
Okay. Hi, everyone. Can you hear me? Okay. Well, thanks, Attila, for the opportunity, and thank you, Chris, for formatting my slides. So, why observe galaxy clusters? Well, it's fun. There's two ways in which it's a lot of fun. One is it's a treat for the eyes, in the sense of the visual sensation that we get from looking at these kinds of objects. And the second is that it's a treat for the mind. When we look at a galaxy cluster, we really get a profound sense of our place in the universe. And so it brings with it a sense of understanding of context. And you'll see that I'll come back to those two themes throughout my presentation, because what is an observation at the end of the day? The observation really is a personal experience of reality. And that's true for all kinds of astronomical observations, but I think it's even more so in the case of galaxy clusters. So here we have a single galaxy, and it's nice to observe. I took this picture at FLO about 2 weeks ago with my DSLR. Can anyone guess what that galaxy is? Yep, you got it. Because usually we see it as a pair. So that's the full picture. I just clipped out M82 in the other picture. Now when we see two galaxies side by side, we actually get a very good sense of contrast in many senses of that word. We can see differences in brightness, difference in orientation, we can see differences in shape, structure, and of course size. Now in terms of size, it's always important, I think, to understand both in astrophotography and also in visual observations the size of the field that we're looking at. Now this field is about 1 degree wide from at the longest side to the other end. And when I look at a field that's 1 degree wide, what that tells me is that it's 1 degree in comparison to 180 degrees of the entire horizon. And that gives us, again, that tells us right away, well, I'm looking at one part out of that 180 degrees. And when you look at in the image itself, whether it's in the eyepiece or on your chip in your camera, we can see that we can estimate roughly the angular size of each galaxy based on how wide the field is. So in this case, M82, I would say it could probably fit about 7 or 8 of those in this field. So the field is about just over 60 arc minutes wide. So you have about maybe a 10 arc minute long galaxy if you look at M82. And it's the same if you use a high power field. If you use a half a degree field, you'll see that you might have about 30 arc minutes in your field in your eyepiece. M82 typically will cover about a third of that field. So M82 is about 10 arc minutes long, or at least it appears so. So the angular distances, you'll see it again throughout my presentation, I'll come back to that. I think that it really is very useful to know the field size and know it very precisely. So if you look at 2 galaxies, or you can look at 3, we'll get even more of a sense of contrast between galaxies. This is, of course, the Leo trio. I showed this photo at the last meeting. This was taken with an 85 millimeter refractor, and I took it up at the end of February at a dark side near Perth. Now these 3 galaxies, each one is slightly differently oriented towards us. Here's my pointer.
Center button.
There you go. Thanks. That's M66. You can usually tell what's M66 because it's more round. That's M65. It's a little bit more edge on, and that's NGC 3628, and it's pretty much edge on to us. And you can see there's the dust lane that's usually visible. This is just over a degree wide. So I've really cropped this picture from my little refractor to get it a bit larger scale in the galaxies. So trios can provide even more visual interest, but the ultimate treat, I think, for the eyes and the mind is a galaxy cluster. Now, many of you will recognize this. This is, of course, the heart of the Virgo cluster. This photo I took at FLO about 2 weeks ago, and this is the heart of the Virgo cluster. This photo was taken with an 85 millimeter refractor. It's actually a stack of about 30 exposures, about 90 seconds long each. This galaxy here is one of my favorite. This is M87. It always looks like a blob in telescopes, but it's believed to be the gravitational center of the Virgo cluster. And these 2 big galaxies here are M84 and M86, those 2. And what we're seeing here is a chain of galaxies that's often called the Markarian's chain. Now, the 3 galaxies here, M84, M86, and M87, are all Messier galaxies. So they're relatively bright, and they're pretty easy to find. They're usually around Mag 8, Mag 9, like most Messier objects. And these other galaxies are between about Mag 10 and Mag 12. So they're not hard to see. And in fact, I've seen several of these smaller galaxies in my little refractor, 85 millimeter. You have to be at a dark side, though, to do that. This chain leads all the way up. Now, the galaxy we don't see at the top that anchors the northern end of the chain is M88. But we'll be coming back to this image in a number of ways throughout this presentation, so just take a look at this. By the way, these galaxies here, these 2, you can actually see some tidal interaction here. They're sometimes called the eyes, although to me, these look like the eyes, but I don't know why these are called the eyes. But these other 2 smaller ones, this is, I think it's NGC 4435 and 4438. So what's better than a galaxy cluster? Well, a faraway galaxy cluster. And these really are my favorite for observing. This one, it's very hard to see the galaxies in this image. This is not a very good image. It's my first attempt at recording something this distant. I took this with an 8-inch scope, again at FLO, and it's a stack of a whole bunch of unguided, about 30-odd unguided 60-second exposures, again with the DSLR. There's a lot of noise in this picture. Hopefully I'll get better at this. But if you look closely, anything that looks yellowish and doesn't look round is a galaxy. There's more than 50 of them in this field. And this is a half a degree field. The field I showed you before, this field here, this is Virgo. This is 2.5 degrees wide. And these galaxies are believed to be about 50 to 60 million light years away. And estimates vary on that. This galaxy cluster is called Able 426. It's the Perseus galaxy cluster. And it's actually visible now, although this is not the best time to observe it. Fall is a better time, but it's pretty low right now in the west at around 8 or 9 o'clock. But this galaxy cluster is about 300 million light years away. And it's considered one of the densest galaxy clusters known. Now this field is about half a degree wide, as I said. The brightest member here is this one right here. I don't know if you can see that. This one, this one here, that's NGC 1275. It's a giant galaxy, and this other one here is 1272. And you can see a parallelogram here, right? Okay. Those are the 4 brightest galaxies. These are around mag 11.5 to 11.8. Those are the 2 brightest. These are around mag 12 and 13. And there's a whole bunch of other ones here. Like there's a triangle over here of 3 galaxies. I don't know if you can see them. Back here. And most of the galaxies on this image are in the mag 14 to 15 range. And that's about the limit for me in my visual observations. I have a 14-inch Dob. And the faintest galaxy I've seen in this cluster is a galaxy that's right over here. There's one right there. I don't know if you can see it. It's actually the star chart that I use is called Megastar 5, and this is listed as a mag 15.7 galaxy. And it is it's not an NGC object. It's in the PGC catalog, which is a galaxy catalog of principal galaxies. But we'll come back to this image as well. Okay, so let's take a closer look at Virgo. How am I doing for time? Because I'm on 10 minutes? Okay. All right. So what I want to do is take you through a visual observation of the Virgo galaxy cluster that I did about 2 years ago. This was in May of 2007 at a site about an hour west of the city. The key to observing Virgo, I'm sure many of you have already observed Virgo, but the key to observing Virgo, for those of you who are new to it, is to find these 2 stars. This is Leo, and that's Denebola at the tail of Leo, and this star here is in the V of Virgo. This star here is called the Ventomeatrix. So if you can find that star and just pan your scope all the way across to Denebola, halfway through, you'll see all these other galaxies. And what I'm going to do is take you through from here to there visually. And we'll also go a little bit further north up here. This one here is M85. It's actually in Coma, Berenices. And if you go further south, you'll get to M49 and M61. All right. So this is the close-up view. Again, you can see the face over here. Face. Okay. And this is Markarian's chain. Now here, this is the chart from Megastar 5. It's a computer software that plots stars down to mag 15, which I find very helpful. If you want to actually identify galaxies that are very dim and small, you need to have a star chart that will show you very faint stars. And pretty much you need to see all the stars that are going to show up in your eyepiece. And so mag 15 stars, Megastar 5 will plot stars up to mag 15, and that actually numbers about 15 million stars. And so those charts are the ones that I would use if I can actually identify member galaxies in clusters. Okay, sorry about the brightness of this page, but I'm going to show you a bunch of sketches that I did when I did this tour of Virgo about 2 years ago. Now, these are upside down, yes, I heard someone say, and that's intentional. That's because I wanted, when you use a Dob, you just invert your star charts, right? So if you want, so when I was sketching this, they're all inverted, so all my writing is upside down, but it doesn't change the little blackened circles, right? So I put them right side up because I wanted to match up with the star charts that I showed you as well as my photographs. So we start from this end and work our way to the other side there. This is north, okay? So at this end is Vindimetrix, and we're going towards the Nebula. Now each of these circles is, I drew it with, this is not the prettiest sketch, it's with a flashlight, red flashlight between my teeth. These circles are using a dust cap from a 2-inch eyepiece. All right, and then I was using Sky Atlas 2000. There's a very nice blown up chart of the Virgo cluster there. And so every time I could identify a galaxy, I would just sketch it in. So I basically went, there's enormous numbers of galaxies in this region, so I just went to basically to the Messiers and sketched whatever showed up in the same field as the Messiers. And if you look at these circles, again, the field size here, this is my low power field. So this is 59 times magnification, and this gives me a 1.3 degree field. So if you, this whole diagonal here is about 8 degrees wide. It's about 2 Telrad circles. And we can see over here at this end, this is like I'm getting right, 8 degrees takes you about halfway between those 2 stars that I showed you. So this face here we can see. Now when I drew this, it was upside down, but right side up, it does look like a face, right? This is M84, M86, and this is M87. Down here is M60 and M59. Now I kind of cheated a bit and did this sketch here because this galaxy looked very interesting to me. And sometimes, going through, like there's about 28 things that are in this sketch, you kind of realize that, Messier saw 16 galaxies in this region. And then you'll see in my sketches, I've actually sketched about 64 galaxies. And again, it's at low power, so it's pretty easy to do this. Now this, again, another upside down sketch. This is the next night. That first night was May 4th of 2007. It was a Friday night. This was a Saturday night. So I spent we got lucky that we had 4 clear nights out of 1 week. So I managed to get out each of those nights and spend about 2 hours each night doing these sketches. This is Mercurian's chain, right? Going up, and you can see it's anchored here by M88, M91. And this is the third night. Again, this is my home base, around M84, M86. Went up north, right? And the northernmost member here is M85. Yeah, that's M85. And this is not to scale because it wouldn't fit on my page, so I just put it in there. I scribbled here that it's too close the way I sketched it. And that over there that's M98. And this is the southern part of Virgo. On the 4th night, which I think was Friday, was a Saturday. It's written down there somewhere, but I can't read it upside down. Now here we have M61 and M49. This is that's M61 right there. So M61 is the southernmost. Now there's north, right? And this is the direction going. This is the direction going back to Vindimetrix. This is M61, and that there is M49. No. Yes, that's right. Yeah, that's M49. And I sketched these two because they're relatively bright. Made me wonder why someone like Charles Messier would not have seen something. These galaxies actually look very bright, almost as bright as M49. So I just put them in there as well. So here I thought, let me put these side by side. So when I was doing these slides, I cropped my image of Mercurian's chain from the photo I showed you, and I just cropped my sketch and put them side by side. And you can see it lines up fairly well. And I was pretty excited at this, so I called my wife over and I said, honey, come take a look at this. And she looked at it and she looked at this thing here and she said, how did you get the distances right? Well, the answer is by being very careful, and by paying attention to what you're doing. So how to observe galaxy clusters? Well, aperture is very important. Now, this is, I think, between 12 and 16 inches, you can actually see quite a few of these galaxies. So you don't need a huge scope. Dark skies are very important. Good seeing and good transparency is very important. Good seeing especially is important because when you want to see really small and faint galaxies, you're going to have to use high power, over 200 times. And when you do that, you want the dim stars, the stars that are on Mag 14 and Mag 15, to appear as pinpoints. Because you will need to be able to tell that what's a star as opposed to what is a faint fuzzy patch. And if seeing is not good, then at high power, it's going to be very hard to tell those two things apart. Dark adaptation is critically important. And dark adaptation, and also using averted vision is very important. Dark adaptation has to do a lot to do with local light pollution. So when we talk about dark skies, we're talking about general light pollution. You want to be away from cities and light domes. But when you look at, you can be at a very dark site, but if you can see distant lights at a farmhouse that's far away, that can ruin your dark adaptation. It means you'll never actually get fully dark adapted. So my favorite sites are sites where there's absolutely no lights whatsoever, and where Jupiter, naked eye view of Jupiter, can be somewhat irritating to the eye. So that typically will take about an hour after you arrive at a site. Now, using power wisely is time. 5, 4, okay, thanks. My 10 minutes has been stretched a little bit. Okay, using power wisely is very, very important. If you're looking at using low power, like on Virgo, you can actually get away with it because the galaxies are between Mag 10 and Mag 12. Now again, I'm assuming your scope is going to be between 12 and 16 inches. If you're using a 30-inch telescope, then low power will show you some pretty faint galaxies. But if you're using a mid-sized telescope, then you need high power to be able to see galaxies that are in the 13 to 15 mag range. And it is especially true because a lot of these member galaxies and clusters will tend to be very small, only about 1 or 2 arc minutes in length. Now, another thing that you can use to increase magnification while maintaining your true field size is to get wide field eyepieces. And that's critically important because typically my high power field will be about 24 arc minutes, 25 arc minutes, about 0.4 of a degree. And I try to boost as much power into that as possible. And so I find using a wide field eyepiece will allow me to increase my power but maintain the same true field. And then again, knowing the eyepiece field size is also very important because that tells you how to estimate angular distances between galaxies and angular size of galaxies. Now, this one might be a little bit controversial, this slide. But personally, I think that tracking is not necessary to observe galaxy clusters. In fact, I think it's a hindrance because tracking is a poor substitute, in my opinion, for something else, which is good mechanics on a telescope. If you look at a star at the celestial equator, typically it's only going to move, 1 degree in about 4 minutes. So if you're using high power and using about, if you have a half a degree field, let's say, you're going to have a good 90 seconds to move your telescope. And what stops most people, I think, is that the scope, when they move it at high power, it tends to shake. There might be jiggles, and that shaking and the vibration of the telescope takes away from some of that time that you have and takes away from the enjoyment that you get when you're panning your telescope with your eye at the eyepiece. But if you have a scope that has very good mechanics, a scope that's very well balanced, then the tracking is not necessary. And the rotation of the sky that you see without tracking, I think, is an essential part of the observation because, after all, if you're trying to get a sense of your reality, well, the reality is you're on a spaceship that's in motion, which is the Earth. And when your eyepiece field is always drifting, you always know where west is because wherever the stars are exiting, that's west. And that's very important to know because in a Dob, if you go 90 degrees counterclockwise from where the stars are exiting your field, that's north. So if you know north and west, well, you know all the directions. And that's very important for identifying galaxies and for being able to take down notes. I typically will use a tape recorder when I'm observing galaxy clusters, and I'll type out my notes when I get home. So you also get to carry less stuff, less battery power. Optical finder scopes, I think, are necessary as well because when you're star hopping, all you're looking for is star patterns, whether you're looking naked eye or looking through a finder scope or looking through your eyepiece. And if you have a star chart that shows you stars down to magnitude 15, you're going to see lots and lots of star patterns, even in a half a degree field. So the key thing is to have a detailed star chart. And if you do that, then you don't need the finder scope at all. And you have to be under a dark sky as well. So what can we observe? Well, we can observe member galaxies, identify them using a star chart. We can count the number of galaxies visible in a given field of view. We can estimate the angular size of each member. We can estimate the orientation of the major axis. Any galaxy that's not perfectly round, it's going to have a longer side and a shorter side. The line that goes through the longer side is called the major axis. So you can always see, is it oriented northwest, southeast? Is it oriented north, south, east, west? You can make a note of that. You can estimate the orientation. You can estimate the angular distance between members. That tells you the relative positions. You can estimate the differences in relative brightness, note any differences in structure that you see, and you can also note the percentage of time that you hold these galaxies with averted vision. So if you can see something 30% of the time, like if you count from 1 to 10, and for 3 of those seconds you can see your galaxy, usually that to me is my threshold, and I can confirm that I've seen it. If you count from 1 to 10 and you only see it one second out of that time, it's kind of hard to know. But typically, if you can see it for 5 of those seconds, you know it's there. And especially if you can see the background stars. If you've got a detailed star chart and you know exactly where that galaxy should be, the stars, the new star chart will confirm it for you, that you've seen it. So quickly, let's go through Perseus, the Perseus galaxy cluster. It's right there, about 2 degrees east of Algol. Okay. Now, my best observation of this cluster was at Nirvana in September of last year. This is the heart of the cluster, and I showed you the photograph earlier. This is a smaller version of the same photograph. I don't know if you can really see these galaxies here, but this is the parallelogram I told you about. Okay, and again, these stars are down to Mag 15. So there's 4 stars here. I don't know if you can see them. That's my landmark that I always use when I look at this cluster, because here's the parallelogram, and these 4 stars are what I always come back to orient myself, and then I'll go from there and find out where everything else is. Like I know this is north going up, and this is east. So for example, when I record 1275 right there, I'll say that's a galaxy that's in the southeast corner of this parallelogram, right? And I can also note that this distance here is about 10 arc minutes, and this distance on this side of the parallelogram is about 5 arc minutes. And that's all very useful information that we can get just from the eyepiece. So accessible galaxy clusters. Again, this is for modest, medium-sized telescopes, like mine is a 14.5-inch telescope. All of these galaxy clusters I've seen in this telescope. This is a very popular one, Able 1656, and this is very well placed now, just slightly north of Virgo in Coma Berenices. This is a very rich cluster, and the 2 central galaxies are about Mag 11. They're pretty easy to get to, and all around them, if you use high power, you'll see more galaxies. Able 2151 Hercules is also a very nice cluster to look at. It's a little bit harder than the other 2 on this list. This one in Leo is fairly easy, 1367, and 262 is a somewhat smaller cluster in Andromeda. So some parting thoughts. I think that understanding our place in the universe has been a preoccupation of ours for a long time. People wondered, is the Earth flat? Is it round? Does the Earth go around the Sun? Does the Sun go around the Earth? What are these spiral nebulae? Are they, collections of stars? Are they something in our own galaxy, or are they island universes? And now we know that they are island universes. We know that they're much more distant than previously imagined. And with very modest equipment, within a short drive of Ottawa, we can actually have a very direct personal experience with these objects.
Thank you very much. Of course, Sanjeev hasn't told you the easiest way to observe galaxies, which is to go with him while he's observing, get him to find the galaxies, then you can look at them. He's got a very nice telescope. Alrighty then. Observing is an important part of our hobby, and we like to acknowledge that. We have a number of observing programs in the RASC where we reward or acknowledge people for completing an observing program. We're going to talk about Tune Planet, Explore the Universe, and an essay certificate. There are a number of people in our club who have received these certificates, but they're kind of bulky, and you kind of can't pin them to your T-shirt or stick them on your hat, so you can't effectively brag with them. So the RAC, in their great wisdom, has decided to hand out pins. And we have a pile of pins here. So I know a number of these people are here tonight. If you are here, please come up and identify yourself to Chris, who has a pin for you. And then if we could all get on stage here, we'll adulate in the applause of the audience. And I will ceremoniously read out the names of these observers: Larry Burnett, Brian McCulloch, Kathy Hall, Chris Tarrin, Dale Armstrong, Donald Dunn, Jeff Meek, Howard Simcover, Jen Tigner, John Douglas, Matthew Weeks, Mike Earl, Pat Brown, Peter Saravolo, Paul Shepard, Richard Taylor, and Richard Prevost. Please come on down.
I didn't wear my shoes.
Are you sure you did all 110?
Oh, I did. Thanks, Chris. Thanks. This is like this.
There must be others.
Wow.
You're on this. Here,
That's terrific. Thank you.
get them over this.
Sorry for the change in screen, but I'm going to be working, and we're recording right now who is actually receiving these. John. Thank you. Yeah. Okay. And Richard. Thank you. And Pat. Thank you, Pat. I couldn't see the back. And who else is that? Kathy? Long? Thanks.
Would you like to assemble briefly for a picture?
And who else is here for what?
Tail arm.
Great.
Are there more pins available?
I think so.
Yeah, Lee, come on up. Anybody else have their certificate that wasn't made there? Because I know we didn't get them all recorded at one point. What's that?
One broken leg.
Yeah, I think he said it's that one.
There's enough for those, some of those people aren't here.
Oh, okay.
Is it Proud Lee?
Okay, let's go. Whoops.
NBC small D over little D.
Look proud, he says, yeah.
Very good. Quick, a little applause for observers, please. A couple months ago, I mentioned that I think an interesting talk would be along the lines of the lifestyles of the rich and heinous. Well, we have one tonight. Welcome Bill Wagstaff and John Sullivan to talk about a trip they made recently to one of the best observing sites, if not the best observing site on the planet, with some of the largest telescopes. Bastards.
I have one, thank you. Good evening. I have a little fiddle to do with a computer, I see. Hang on. From beginning, there we go. There we go, that's much better. John, my wife, John is not my wife, but John, Coma, my wife, and I recently visited Chile for vacation for John and my wife. 3 weeks. Myself, I stayed a week longer, a month. Most of the time was spent doing the normal touring sorts of things. But we did take an opportunity to head north while we were there and visit one of the better known and larger observatories in Chile. So the talk this evening will center on our trip north and what we saw up there. So it's kind of a travelogue, a few travel slides, so to speak. Okay, flight down to Chile, it's pretty much direct. There's a direct flight from Toronto, so we just jumped on a plane, short hop to Toronto, and then off we went for 10 hours. 10 hours in a plane seat, of course, you can guess what that was like. Okay, the flight starting from, if we were at the museum here, and if everything's working properly, off we go. We head down the South American coast to just about the center of the country, and we find ourselves looking at Santiago, Chile. Santiago is quite a large city, very metropolitan, as you can see here. It's backed up right against the Andes. The Andes are right up to the city. The rest of the time we were there after our first week, we stayed in Viña del Mar, and that became our base of operations. Now, Santiago de Chile, metropolitan population, about 7 million. Quite an old city, and very polluted, as you can see here. It's contained within the Andes to the east, and there's a central cordillera as well, another backbone of mountains running down on the other side of it, so it's really captured inside those mountains. And the pollution pretty much hangs there all the time. This is early morning. It does lighten up a bit during the day as it burns off, but it's still pretty thick. Okay. Once we had spent some time in Viña, we headed from there northward up the coast, about a 4-hour drive, to the town of La Serena in Chile. La Serena was a stop there, just a little site we saw along the way, a row of wind generators, very windy up along the coast there. La Serena was a stop for us because that's where we had to go to the university to pick up the all-important permit. You can't go up and tour the observatory unless you have permission or an invitation from the university to do so. So I had contacted them a couple of months in advance and got the okay to head up. Once we'd picked that up, the next morning we headed from La Serena eastward up into the foothills of the Andes to the city of Vicuña, town. It's relatively small. And then the following morning, our tour took us up to the top of Cerro Tololo, which is just to the south of there. CTIO is the oldest foreign observatory in Chile. It's operated by the NOAO, U.S. organization. It's fairly high up. It's about as high as most of the peaks in that area are, so it has a very good horizon. The branch off of the road, the initial sign, great excitement building for John and I, looking forward to it. And you can see the road headed off into the mountains from there. We ended up waiting in line. There's a security gate, and there's a fellow there who needs to check your permits to let you in. Finally, they were all checked. The gate opened, and of course, as I say, keep an eye on that Toyota. He's off like a shot ahead of us up the hill. We're a little slower driving a Toyota. We come around the first curve, and oh my, what's that? He's in the ditch. Okay, and so we slowed down and checked, made sure that everyone was okay, and then we're off to the observatory. We're not hanging out here. Off we went. So heading up, pretty steep climb the last couple of kilometers. There's quite an incline, and we found ourselves up on top. Beautiful sight. Equipment was provided, as you can see. Some objects look very distant. They were somewhat better once we turned the telescope around, and some less experienced observers in the crowd, I guess. So the first telescope we toured was one of the 4 telescopes currently operated by the SMARTS Consortium. They're a consortium of universities who remotely access these from university sites in the United States. They're used as part of astronomy programs. So they have an online scheduling system that allows them to book time on the telescopes. They're pretty heavily utilized. So the 1.5 is the largest of those. There's also 3 others, 1.3, 1.0, and 0.9 meter. And you'll notice I'm not mentioning the big one there. Okay, got in. The 1.5 meter is a fairly conventional open frame, what is it, Richie Chrétien design, as I understand it. Like most professional telescopes, has covers over the mirrors. Those things that look like petals there are the actual covers on the mirror. So they briefly opened them up to let us take a look at that. I'm afraid I was not on the ball and didn't actually catch a glimpse. But here they are almost closed again, me frantically trying to get a picture. There's a number of instruments that are mounted to this telescope, both spectrometers and cameras as well. We didn't actually get a description of exactly which one was which, and I didn't think, well, some of you might actually be excited by the details, but in the interest of brevity, we didn't get into it. We did notice, however, on that gold-colored instrument on the bottom, it was venting vapor. It's cooled by liquid nitrogen, so they'd clearly filled it up sometime recently. For the astrophotographers in the crowd, you'll recognize the flat field target was mounted up on the side of the dome, ready for them to take flat field images for calibrating the visual cameras. Okay. A little larger than the kind of hand control we're accustomed to on our telescopes, built by a reputable company, Westinghouse. They also have a small hand control, but I found it a little interesting to see the size and weight of this equipment. So, of course, on from there, the Blanco 4 meter, the largest telescope on the hill. This one was commissioned in 1974. It's nearly a twin of the male 4 meter that's on Kitt Peak in the US. About halfway, thank you. The primary application of this telescope is for wide field imaging, and it can be used either at prime focus with an F ratio just under 3, or at the RC focus at F8. So it's a fairly versatile instrument. They have a number of different cameras and spectrometers that can be mounted to this telescope. I guess the most significant thing I could say is it was so big it was hard to get into the camera viewfinder. This is running at 24 millimeter. I'm right against the wall, and that's all I could get in of it. It really is pretty big. The cage underneath, and you can see one of the brakes here for the main ring on it. Okay. While we were there, we noticed some equipment around that forced me to look up online what was going on. Turns out they have equipment for washing the mirrors and also for aluminizing the mirrors right there beside the telescopes. So they don't send them out to a shop or anything. They do their work on site. This is the washing chamber right next to the telescope, and you can see a kind of irrigating rig beside it that's used for rinsing off the mirror. So they'll dismount the mirror out of the telescope and place it in here, clean it up every few months, and then they'll mount it back into the telescope and recollimate. There's also an aluminizing chamber alongside. You can see the washing chamber to the right there, just down here. This is the aluminizing chamber. It's a large vacuum chamber that they can use for reapplying the coating onto the mirror. Looking up online, I was able to find a few pictures of the last time they aluminized the 4 meter. You can see in the right-hand picture here the cell in the back, and here it is in the front in this photo. It's got a double ring of actuators that are used to twist the shape of the mirror. This is the base of the aluminizing chamber that's been taken off. You can see the chamber's kind of suspended for the moment. And this is the mirror. On this side, the mirror is removed and sitting on the floor, but it's still got the aluminum on. In this one, you can see now it's been stripped of the aluminum, so it's ready to be inserted into the chamber. It's kind of an interesting thing. One more item we saw up there, the prompt system. The prompt system is intended to hunt for gamma ray burst afterglows, which are very brief. So the idea of these they're a bank of 6 telescopes that can very rapidly slew over to a given position. They simultaneously slew over and image whatever the origin of the gamma ray burst is. The domes are not on the main peak. They're off to the left in a slide ahead. You'll be able to see the location of those domes. But those 6 domes here are the 6 prompt system domes. This is another dome for another reason. They each have a 0.41 meter RC Systems Ritchie-Chrétien. Each of these telescopes has been hand-tuned to a different wavelength. So each one is imaging at a different wavelength, and they're examining all of the images simultaneously to see what they can find out about GRBs. Okay. Just a little bit of a panorama John shot. I popped it in because it does give you a good idea of you're up on top. You're really looking across the tops of all of the mountains around you. You're about the highest place there is there. Okay. So from Cerro Tololo, we got done there. We're just going to swing around a bit so you can see. Here's a set of prompt domes down here. So we had previously in that image been looking at the top. It's just on a shelf a little below. And if we look across, we see a couple more domes on the next peak. This is Cerro Pachon. It's part of the same complex, operated by the same people. It's got 2 more domes, the little one here and the big one. Well, when we pointed that out, the guide they gave us said, oh, well, that little dome is the same size as the large one that you're just looking at right now. The other one is an 8.1 meter telescope, quite a bit larger. So the 4.1 on Cerro Pachon is known as the SOAR telescope. General purpose. It's fairly advanced. It's got active motion of the mirror again, 120 actuators underneath, very thin mirror. So it's adaptive optics, very modern design. The telescope beside it, the 8.1 meter Gemini South. It's one of a pair of matching telescopes, thus Gemini. This one in Chile is matched by another one that's in Hawaii. So they use them jointly to do comparison across a large baseline, a long baseline. Yeah, the distance between the two sites, essentially. So in some ways, you could consider them to be two sparse points on a mirror that was that large. So the resolution is very high when combining the images. Okay, the Gemini South, an 8.1 meter Cassegrain. It's a little bit higher than CTIO is itself. Interesting in that they use protected silver coatings rather than aluminum coatings on it. They have higher reflectivity, especially in the infrared. So it's really a telescope that's tailored to infrared observation. Uses a laser guide star and, as I said, adaptive optics. So very interesting, very advanced telescope system. Last thing on our trip, how's our time doing, Attila? A few more minutes, good. Last point, we went down to a tourist observatory, as they call them. They're operated by the, well, if it was here, it would be the members of the Ottawa Centre, would be running a roll-off roof observatory. The only difference between here and there is we do public astronomy for free, they do it for money, okay? So this is their observatory dome at Observatory del Pange. Inside here, they've got a 16-inch Meade Schmidt-Cassegrain telescope. They're setting up to have an Obsession 25-inch. They have the scope, but they're building another observatory to house it right now, so it's not active. Anyway, for 3 people, 18,000 pesos. Equivalent to about $36 Canadian for 3 people. That took us up there for about 2.5 hours observing on top of the hill. It was recommended to us. These guys were real astronomers, not tourista guys. They really knew their stuff. They let everybody do a lot of observing, very little talking other than pointing out and identifying objects. Great place to go to. I would highly recommend it. The best 2 hours I've spent in quite a long time. Okay, and John's just going to talk to you a bit about what we saw while we were there.
Yeah, originally when we were going down, we weren't going to go to one of these observatorials, but when we saw the skies, it was just we just couldn't say no to going out. On a bad year, they only get 300 clear nights, and they're just amazing, So we go there. So this is from Carte de Ciel. We didn't really have any good cameras or pictures there, but that sort of gives you an idea what the sky was like that night. It was just sort of, that was naked eye, just pretty much about that. And we got to see a whole number of different constellations that we wouldn't see. Whoops, wrong button. Which one? As we take a look here, he couldn't exist if you take a look as Orion is. We figured he was on holidays too, because if you notice, he's sort of upside down having a little sleep. He's not different than what we're used to, and but again, that's because you're looking at it from a different way. And then also too, one of the things we noticed is that the first night when we were looking just from where we were staying, is we found this here and we thought, oh, we'd seen the Southern Cross, or what they call the crooks down there. But then when we got up there, we noticed there's also one down here, and we're not sure which one. And of course, this one's crooks, And what we also found out is that if you look, is that there is no Polaris down south, So what they need to find other things for navigation. So you find if they take, I believe it's these two, and you go another you take that distance, you go about 4.5 times that, you find the southern pole. And so that's what a lot of people used to use for navigation. And what would happen often is they would get Vela, which is one here, and then they'd end up crashing into all sorts of things. So it's a good thing we had a map, because we were following Vela. But anyway, and this, of course, is Vela. It's got an 8-burst nebula, and it's often mistaken for Crooks, which is the formal name for the Southern Cross, and has caused all sorts of navigation problems. And also, Vela used to be part of a larger one, which has been broken into a number of different constellations. One, of course, being Bootes. And the other thing we found interesting, of the 88 known constellations, the Southern Cross is the smallest of them all, but it also seems to have a lot of impact. I think there's like 8 or 9 or 10 countries that have flags based on the Southern Cross. So, and then there's we found a number of interesting things, like right in the middle of the Milky Way here, just above the crooks, is the coal sack. and there's a picture of the coal sack, which is again just a dark nebula that comes right out in front. And again, it's just plain view. You didn't need to. You could just see it with your eyes. The sky was so. It was just a thing. And then we started looking at things like the Large Magellanic Cloud and the Small Magellanic Cloud. We brought a thing in here to show you. It's just a number of the satellite galaxies to our own Milky Way. And so, first off, there was the Large Magellanic Cloud, and you see it's there, and you notice it's got a bit of a bar shape. And what a number of people are thinking is it was originally a bar galaxy, but from the Small Magellanic Cloud in relation and the Milky Way, as it's starting to have an impact on it and spread it out, it goes. And then you'll notice up here there's a little bit of a thing, which is the Tarantula Nebula, which is one of the major star-making systems, and it's amazing when you're looking at that, because when you look at it, is both the Magellanic Cloud, the Magellanic Clouds, you don't need anything to see them. They're just a plain eye occupant, and then you start putting telescopes and binoculars on them. They're just amazing. But the Tarantula Nebula, or the 30 Doradus, is you can't see that with the naked eye because it's just so close. But when you start putting it on, it was just amazing. And then of course the Small Magellanic Cloud, which is right here, and it's the same thing. And again, it's naked eye, and you can see it, and it was just amazing. And then of course right underneath it, right underneath it here is 47 Tucani, which is a large globular cluster, and it's the second brightest globular cluster in the sky. And if you go off the other side of the Milky Way, you find Omega Centauri, which is the largest and brightest globular cluster in the sky. But we spent 2.5 hours, and we went on and on and on. And Bill and I were fortunate. We were the only two of the group that went up. We took our own binoculars with us, so the guides were really, really good. So they showed us. I think I spent that whole 2.5 hours with my binoculars almost glued to my eyes because there was just so much to see, and and the guides were just very, very good. So it was a trip well worth it, and I'd recommend if you're going to go down there. If you go down around there is the observatory that you see in the guides is Mamayuka, and what we were told is that Mamayuka they tend to talk more than let you observe, and I don't know if that's true or not, but because we went to these folks, but they're just excellent. They let you observe, and they show you the different things and help you, and the more experienced they think you are, the more challenging they get with the areas that they're going, or the sites or the targets they're trying to give you. And I was just amazed, and I think Bill was even amazed by it too. Is the guy with this pointer, as he'd point, I think this is right about here, and he'd be bang on every time. It was just, it's obvious he's been up there more than one time. But when you get 300 plus observing nights a year, I guess you get that opportunity to get to know the sky pretty well. But anyway, that was our trip. Thank you very much. I guess, is there any questions?
Okay, well, I guess this is going to be a bit of a deja vu, but we'll go anyway. Let me see if I can select the right one right
Left and
away.
right button. Yes. Oh no, that's not the top button, the left and right button.
Oh, man.
You realize, of course, I sent an email out with detailed instructions on how to operate that.
I know.
And
Okay,
there's a
so
sheet
that...
right here with the buttons labeled on it.
Oh, God, that's right.
He's an engineer, he can't handle it.
Yeah. Dark screen.
It works.
Right. So the challenge here is how many galaxies? And we've already explored this area, and this will be a refresher, I guess. Where's the pointer?
Middle button.
Oh, okay, that's fully integrated now. Okay, so we have, once again, we have Arcturus here, and the Big Dipper up here, and Regulus over here, and down here is something called Corvus. So basically, this is what you see when you go out about, anywhere between about 9 o'clock and midnight. You just look to the south or practically straight up, and this is what you see. So on a star chart, what you see is all these galaxies, right? And so this is what we're going to zoom in on eventually. So this is the what's called the Coma Virgo cluster of galaxies again. And it's part of a supercluster that we're part of. And that sort of makes it difficult to know how far away these galaxies are because there is still some gravitational attraction. So redshifts are not a good way to determine how far away these are. They're too, basically they're too close for redshifts to be very accurate. But then again, they're too far for things like Cepheid variables to be easily detected in these. But I think general consensus is around 50 million light years, something like that. Right. So going a little closer, and you see what it is here. All these green labels are galaxies, right? And once again, sort of in the middle is M87, and that's kind of the mother galaxy. And here is Markarian's chain. And all these other galaxies around it, all the way basically to us, is kind of the edge of this big supercluster. Okay, so there's Markarian's chain, a slightly different spelling than we saw before. I'm not sure what the right one is. But again, here are M84 and M86, and now we're starting to see that there's a lot of other little things here. All right. So the idea here with this challenge is to take your field of view of your telescope, and this is fairly realistic. This is about a 1 degree field, and put the telescope in such a way that either M84 or M86 is located in the field, and count the number of galaxies that you see. And the funny thing that happens is as you increase the magnification, you see more galaxies. So on the one hand, with a lower magnification, you have a wider field of view, you might see more galaxies, but then as you increase the magnification, some of the things that you thought might be stars are actually galaxies. So you may actually see the same number of galaxies regardless of the magnification you use, and this is kind of an interesting thing in the universe called self-similarity, that no matter what scale you look at it on, it looks the same. And here are some of them labeled. And this is about what you'd see in, say, a low-power telescope field. And so how many of these are actually labeled here? Here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 labeled, and maybe a couple more. So 12 is actually, a pretty good, decent number that you should probably have no trouble seeing about 12 galaxies. But again, you look a little deeper, and you'll find that eventually the galaxies will outnumber the stars, and a lot of them are labeled here. You probably, in a good sky with, as was mentioned before, a 12 to 16 inch telescope, you probably see the galaxies brighter than 15th magnitude, which in this field there's probably about 20 galaxies brighter than, no more than that, maybe 30 galaxies here brighter than 15th magnitude. So that's the challenge. Center your telescope field on having at least one of these in the field of view. Probably best to have, these 4. That's going to get 4 right off the bat there, and see how many more you can count.
I have a question for you, Rolf. When we do these deep sky challenges, we tend to get reports back from people with images, with photographic images.
Oh no, that doesn't count. No.
So I wanted to clarify.
Right.
It's a visual observation.
So what you have to do here is come back next month with just a number, okay, and report back on how many you saw. Just come back with that number. How many did you see here?
It'll be contest. Who can think of the biggest number?
So we'd like some drawings of what you saw?
Well, I mean, that's tedious. Just count them. So, sure, I mean, yeah, if you're so inclined, but.
All right, thank you, Rolf.
Okay, so that's it. Okay. I have to acquaint myself now with this control. Okay. Okay, so this is, again, we saw this earlier, M81, practically straight up now. And almost naked eye, a very bright galaxy. So this was about 110 minutes with a 6-inch refractor and Canon 40D. So a series of 3-minute exposures, because that's the longest I can do without guiding. So these are basically 3-minute unguided exposures all stacked together, about 40 of them. And then M82, same thing. This was only about 20 minutes. Tracking was very poor on this, so I couldn't use most of the images that I took. But again, this is the, whoops, I didn't mean to do that. But this is the one that's got a lot of stuff happening in the middle there. Okay, that's it for
I
me.
believe astrophysicists call that stuff a starburst galaxy. And they don't actually know why a galaxy is blowing up, so I guess stuff is perhaps accurate.
Yeah, I forgot to mention again, this is again with the 6-inch telescope and Canon 40D. I didn't quite get enough of an overlap between the two so that I could mosaic them together, but they are pretty close together, M81 and M82, but I'd have to take another field with stars in between, I guess, to get them both.
Thank you, Rolf. Next is Paul. Paul has a few observations and a news report.
Right, this is ARP 278. It consists of two galaxies interacting with each other. I thought tonight I'd show you things that aren't illustrated on the front of magazines or something. These are kind of peculiar and weird things that you see deep down in the sky if you go deep enough. Now these two, I dedicate this picture to my friend because I think that you've done more than anybody, Attila, to bring this out. So you can probably see these because these aren't very bright. The top one, 7253A, is 14.4 magnitude. The bottom one is 15.0 magnitude. So you'd have to have a pretty large telescope to visually see them. Photographing, no, but to visually, you're one of the few, Attila, that can see this. This, by the way, is in Pegasus. It's called ARP 278, but those are the two interacting galaxies in there. And I thought, as I said, that I'd show these things tonight that not normal stuff. Okay, next. Okay, this is NGC 7741. This also is in Pegasus. It's a barred galaxy. But you notice it's a bar and it's got weird type of I don't know what you'd call them, these arms or wings or whatever. It's also a very peculiar galaxy. This one you could probably see. It's an 11.8. So if you have a 10 or a 12-inch telescope, I'm sure somebody like Gary Boyle could pick that up, I'm sure, if he wanted to, on a 12-inch. That is not too dim. But that also is in Pegasus, and it's a sort of a weird, peculiar type of galaxy. Okay, next. Now this is a real, as you can see, this is a very peculiar thing. This is an S type of, it's also a barred spiral. It's in Pegasus. It's 11.6. And it's 4 by 3.1, so it's a fairly large one. You should be able to see that in an 11 or 12-inch telescope. As I say, this is odd. You don't see things like that normally. You have to go deep in the sky to see these things. So Attila, I took the advantage. I thought I'd show not your regular stuff, but the stuff that you don't normally see. But I have one announcement now before I sign off. Many of you, including Attila, have this information already. It's not an April Fool's joke, but it's dated April the 1st from NASA. They've announced that the sun has plunged into the deepest solar minimum in nearly a century. In 2008, the sun had no spots 73% of the time, a 95-year low. In 2009, the spotless rate has now jumped to 87%. We are currently experiencing a stretch of 25 continuous days with no sunspots, and there seems to be no end in sight. And by the way, nobody knows why this has happened. Thank you.
Thank you, Paul. Next is one image from Doug Loma.
Where's the pointer?
I got it.
So if you can see these small rainbow type features right there, those are colloquially called sundogs. It's one of the most common type of halo feature that you can see around the sun. One suggestion I have is always wear sunglasses. Without sunglasses, these things look very bright and very whitish, so they're almost hard to look at sometimes. As soon as you got a pair of sunglasses on, you can definitely see the rainbow type colors in them. They're caused by light refracting through these ice crystals high up in the atmosphere, and it's a very pretty sight. This is a new digital SLR camera, and I took 3 images with a 50mm lens and then just stitched them together digitally.
Where was that taken from?
Oh, just from my balcony. Tuesday, March 24th.
Balcony on Cerro Tololo.
Scott George?
Sure.
Button in the middle?
So just recently I disproved there's a theory that whenever you buy a new telescope, it immediately rains for a month. Anybody had that experience? I bought a new telescope and it cleared up for a month. So I got, okay.
Cerro Tololo?
Actually, it's a Cerro Volo astrograph. So it's very close to Cerro Tololo, Cerro Volo. So this is actually showing the whole field instead of zooming in on the object, so maybe you can't see it that well, but that is the Eskimo in there. I guess you have no way of zooming that in, do you?
Can. Awkward.
Can you do it just quickly? Oh, if you can't do it, don't worry about it. Okay, that's a little better. Go all the way up. Go for the gusto. There we are. That's a bit over zoomed, but there you can see the details. So that's why it's called the Eskimo. It's got the fur hat. The seeing was fairly decent, around 2.5 arc seconds, full as half max, which is decent, good Ottawa seeing. It gets a little better sometimes, but not a lot. Okay, back to the show now. I don't know if you can. Okay, thank you. All right, let's see here. Okay, I also took a shot of M82 with the same Cerro astrograph. I'm using an Apogee U9 CCD camera for these. This is actually on 4 filters, actually 5, sorry. LRGB plus a little bit of the sulfur 2 in the middle here added on there. So we get a view some of the more of the starburst stuff that's going on in the middle of the galaxy. Okay. Let's see here. Ah, yes. Part of the Leo trio. This is the Leo duo. Now, my scope doesn't have quite enough field of view to get all 3 in there, but I can certainly get all 2 in with a fair bit of resolution. So that's 65 and 66. You notice a nice bar here on the spiral, and the arms coming off. And this is just a run-of-the-mill spiral. But they have some nice colors in there. You can see some of the blue and the purple magenta colors from the spiral arms. Okay. Messier 13. Now, this is the shortest exposure of the lot. It took me 15 minutes, and I probably didn't have to bother going that long. Again, it's an LRGB shot, and it shows, you can see there's 2 different sort of families of stars in there. There's sort of a bluish stars, and there's yellowish stars, which is kind of interesting. I think there's one more, isn't there?
2 more.
2 more? Okay. Who? That's the Owl Nebula. This is 8 hours from 2 different nights. It was a pretty faint object. It's actually fairly bright, but it's got a very low surface brightness. It's big. So it takes a lot of exposure to get a good image. The last time I did a picture of this was on film, and I could barely register it on 1,000-speed film. But the CCD camera picks it up quite nicely, and you can also see some color. Oops, wrong button. Can you back it up for me? Thank you. No? Okay, I got it. All right, this button here. You can actually see some little red fringes around the edges, as well as the blue. And of course, these are the eyes that give it the name Owl Nebula. And last but not least, the Crab supernova remnant. So we can see quite clearly the debris from the supernova explosion. And what I found was a little bit interesting. Some of these little tendrils here are more magenta and some are more red. I don't know if there's anyone around who can give me a good explanation for that. Maybe it's reddening from dust or something, but it's a very, very pretty object. Of course, the Crab pulsar is there in the middle. That's the source of all this mess, and exploded about 1,000 years ago, something like that.
Just a question, Doug. Does Mercedes know how much you spent on this telescope?
Yeah, she wrote the check.
Oh, I just remembered. But you can write them off in your taxes, can't you?
This is all business expenses.
Bastard.
Yeah, so that's a Cerro astrograph.
What size?
It's 300 millimeter, 30 centimeter, 12 inch. Sorry, I have to talk. Well, it's two Fs. It's either f9 or f4.9, depending on which lens you put in the back. And it's got a really nice wide flat field. In fact, it's got such a large central obstruction. When you put it out of focus, it looks like a ring. But that gives you completely no vignetting across a very large field of view. So it's a gorgeous scope for taking astrophotos and for doing wide field things as well.
What software do you use?
Funny. Maxim DL, funnily enough. Photoshop. You know, I know just enough about Photoshop to be dangerous. You have to get Deborah to work on it or something. But Maxim DL I know really well for some oddball reason, but Photoshop, I'm just, I've never really learned it properly.
What's the camera?
The camera is an Apogee Alta U9. It's a Kodak 6303 sensor, so it's 6 megapixel, 9 micron pixels. And it runs typically at minus 30 degrees C. It does that almost year-round, except in the depth of winter when sometimes I have to lower it when the outside temperature gets too low. It won't regulate. If the outside temperature gets below minus 30, it won't regulate the camera. I have to push it down. So the cooling makes it really nice and quiet. It gives you nice, clean images like this. Okay.
Let us know when you'd like to give us a tour of your observatory.
Okay.
Thank you, Doug.
Thank you.
Okay. Okay, thanks Attila. If we could go to the first slide, please. All right, so what we've done this time is we've got some pics here. One pic from Murray Campbell, and it's the Isabel Williamson observing program. So it's item number 36 in that program, and the area is Lacus Mortis, the Lake of Death, and the crater Berg, and you can see the Ruckel chart number there. We'll just go to the next slide, please, and just to show you where it's located. All right, here's your point with the button there.
Push the button?
Push the button.
Okay, it's in the northern area.
Can you stay on the mic?
Pardon me?
Get on the mic there.
That's okay. I can speak loudly. It's in the northern area. Our big, huge indicator where why I'm doing this is because somebody asked me about it. If I would do something, I was thinking Apollo moon missions. So anything around there is what I suggested. So near Mare Farigis, halfway between the two, is Lacus Mortis. Next, please. There we go. It's instantly recognizable as this big, huge berg in the middle, and just north of it is Bailey, and there's, well, you can't see it, but Hercules is off the side. This image is what inspired me. Thanks, Mike. He did this 2 years ago, and I took a look at this. Some of the really neat things about it, I used a Newton 4-inch scope, and I was able to pull out some of this detail. I was noticed that because of where it is, it's rather arched. So people with even small scopes should be able to look at this. More challenging, the larger scopes, we'll be able to see these neat little sea creatures. Anybody recognize that? Yeah, in the lake, that's correct. Domes, rails, reme. And what's really neat is that between 3 days and 5 days, the shallows are really neat. And the opposite end, 15 days, 17 days, you get a reverse. So you actually get to see some of these pimples and elevation points along the edge of the larger crater area. But if you compare it, you should be able to see the cross of death in the middle of this lake. So anybody go see it, let me know what it looks like. I only saw it once.
Can you point at the cross of death?
No, I'm not.
Oh, okay, you're
not no, that's the challenge. Find
right.
the cross of death.
Find the cross of death. All right. Okay.
Yeah.
Thank you, Murray. All right, and I just want to say that's really neat. Very interesting area to observe. Now, last month, if you recall, the lunar challenge was the Aristarchus area. Can we back up one image, please? Aristarchus, of course, is the bright crater right there, and we actually had an observation of Aristarchus. If we can go one more and one more still. Okay, this is what it looks like here. Okay, there's Aristarchus and Herodotus. Okay. Now, somebody observed this and submitted a sketch, and in fact, it was Murray Campbell. And if we can pull that one up, he did it while we were doing a presentation from his seat. That's a sketch on the back of Astronauts. All right, so you can see the Aristarchus there, Herodotus, and there's a very nice feature there. You can even see, look at this, the plateau squared off there. Now, I have observing notes from him. He says the observing conditions were somewhat comfortable, sitting in a seat. but rushed due to limited period of prominent observation. The atmosphere was clear observation with some haze and local disturbances. I'm not sure what that means. Right? And just since we were talking about Doug's processing and everything else, for Murray, the processing was hand-sketched and using a commercial Papermate blue ink pen with shading on secondary features. All right, so there you go. Thank you.
Thank you, Brad. Thank you, Mary. Wait, the fun is not over yet. This is where I get to tell you about the coming entertainment and coming events. Right after this meeting, your hosts, Anne and Ann Fraser, are going to, Art and Ann Fraser are going to feed us caffeine and carbohydrates. So I'll give you a second chance to see the displays out there. Thanks to Mike Mognahan for organizing the table displays. For those of you who need something a little stronger, like alcohol and real food, we have a standard reservation at Kelsey's across the street. You get to sit down with this charming bunch. A couple of other announcements. Apparently, there's no particular date for this. The International Year of Astronomy is having a writing contest. I believe it's for younger folk. If you're interested, grab one of these. This Sunday, Mike Mognahan has organized a solar star party at Chapters Canada. That's in Chapters Centrum. You know that beautiful 6-inch telescope on the astrophysics mount with the high-end solar filter? It's going to be there. You'll get a chance to look through it. Now, Paul did point out that there won't be any sunspots, but even when there's a quiet sun, usually we can see filaments in hydrogen alpha light, and I'll have a high-resolution white light telescope. There we should at least be able to see the solar granulation, or you can come just to drool over the high-end equipment. On the same day in Cornwall, Terry Hildebrand, who is a real-time support manager for the Canada Space Arm, will be giving a talk. This talk was organized by the Glengarry Stargazers. It's in the Best Western Hotel. The next meeting will be Friday at 8 p.m., May the 1st. And Simon Hamner is going to grace us with his presence again. It's going to be a very interesting talk about the outer solar system. Immediately afterwards is International Astronomy Day, Saturday, May the 2nd. There's going to be a large program here at the museum. There'll be daytime activities. I believe there'll be a few activities for kids, including making a planisphere, I believe. The Helen Hoyer-Salk Observatory will be open on May the 2nd. There'll be a talk about Champlain's Astrolab by Dr. Randall Brooks, and there'll be a star party at 10 p.m. I believe Mike Mognahan will be organizing volunteers from us to support this event. On April 30th, Jeffrey Cockhill, who is a member of our society, is giving a talk called Solar System Odyssey at the Gloucester Senior Adult Center, which is on Ogilvie Road. And, oh, by the way, tonight, Tim Colt says that if you didn't get a chance to look at the Helen Hoyer-Salk Observatory from the inside, he's going to open up the door again this evening. And all that remains for me is to thank the very large numbers of people who helped make this possible. Special thanks to Chris Tarrant, who labored endlessly to get the slide panel working. And to Richard McDonald, who is not just a pretty face handing out our prize tickets, but got the audio working today. And to Mike Mognahan for organizing the tables displays out back and the Solar Star Party tomorrow, and all of our speakers, and to you, the audience. Thank you very much, and have a good evening. That's the